Howdy and welcome back. So let's begin exploring how we can add edges between the vertices of our graph. So let's go ahead and just review how this might look. So let's say we have some function add edge, which will take the names of two of our vertices. We're probably going to want to make some checks here to ensure that, hey, both yellow and purple are valid vertices within our collection of vertex. And then what we would also like to do is ensure that there's not already an edge between them. Now, if these two constraints are satisfied, we can actually go ahead and begin to create that edge. And how we do it is quite simple. To create an edge between yellow and purple, this function, after making the prescribed checks, is going to create an entry in purple's adjacency list with yellow. And then it's also going to create an entry in yellow's adjacency list to purple, since that edge is undirected. We can travel from purple to yellow across the edge and yellow to purple. That's what we mean by that we're adding a undirected edge. There's no directionality to it. And we can see here that despite adding two entries to two different adjacency lists, we're still going to consider that the addition of a single edge. So we can see here, just walking through these motions again, if we wanted to add an edge between blue and yellow, we'd go ahead and we can pass strings of those colors to our add edge function, provided they're valid vertex in our collection of vertices. We can go ahead and check whether or not an edge exists between them. And we, just by looking at this quick, it didn't before. So after, we will go ahead and create that edge by adding another entry to yellow's adjacency list to blue. And then what we're going to add to blue's adjacency list is going to be yellow. And adding these two entries to two adjacency lists, we have set up an undirected edge between blue and yellow. And again, despite making two adjacency list entries, our number of edges has only incremented by one. So what does this look like? Let's go ahead and move on over to VS Code. So my add edge function, as the slides kind of alluded, is going to have two parameters, v1, v2, both are constant reference to const of string objects. First thing we're going to do, although we might trust the user, we're going to verify that two valid vertices were passed to this function. Because again, add edge is it's accessible by users of our type. So we'll go ahead and check. And if either of the vertex pass does not exist, we'll go ahead and throw a runtime error. In hindsight, maybe these both should have been standard library and valid argument typed exceptions, but let's just keep going forward. The next thing I'm going to do is check whether v1 and v2 already have an edge between them. And how I'm going to do this is through a helper function that I implemented. It simply returns true or false whether there is an edge between v1 and v2. And since our add edge function is going to ensure that every edge added to our graph is an undirected edge, in making this check for adjacency, we could use either v1 or v2's adjacency list. So how do we get an adjacency list from that map? Well, we're going to go ahead and say, given the key v1 in graph, go ahead and give me back the value map to, and that's going to be v1's adjacency list. And we're going to go ahead and store bind it to a reference to that's const. So we can't inadvertently add to it or interact with it or mutate it in any sort of way inadvertently. Okay, so once we have that, we're going to use the standard library's find algorithm. And I mean, you easily could have wrote a for statement to just loop through each entry. If you get to the, if you've looked at every entry within that list and you did not find v2 effectively, it's not adjacent. But I just wrote this to maybe make it a little quicker But I guess it required a little more explanation. So we're effectively saying from the beginning of our adjacency, V1's adjacency list to one past its last element, try to find V2. This effectively returns something reminiscent of a pointer, should it find it. If it doesn't find it at the end of this function, what's returned will be a pointer to one past the last element. So what we simply return is, hey, if it is not equal to one past the last, we're going to return true because we found it. Otherwise, if it is equal to that, this function will return false, thereby indicating that V1 and V2 are not adjacent. And that's what we're looking for in this case, because we want our edges to be unique. Okay, so if no edge, if they're not already adjacent, we can go ahead and create the edge. So we'll go ahead and access V1's adjacency list. This part of the statement, this expression here is going to return a reference to V1's adjacency list. On that adjacent, so this dot pushback will be applied to the adjacency list returned by graph dot at V1, and we're simply going to pass back V2, and that is creating the first entry into our adjacency list. So if we're doing, blue, yellow, blue's V1, bound to V1, yellow's bound to V2. Okay, first thing we do is we're getting blue's adjacency list and we're adding yellow to it. Okay, and then the second part is get yellow's adjacency list and add blue to it. And that's what the second pushback statement right there is doing. And then since we've added in a single undirected edge, we're going to go ahead and increment number of edges by 1.